Hello everyone, I'm at Arizona State University's Solar Power Lab and I am talking with Dr. Hansberg, who is the director of this amazing facility. And I wanted to ask you, what type of research is being conducted here at the Solar Power Lab?
Okay, so we research in high performance solar cells. Solar cells are also called photovoltaics, and what they do is they convert sunlight into electricity. And so in the last decade or so, there have been absolutely amazing advances in increasing their performance and in reducing their cost. So what we're doing now is still trying to further increase the performance. So in various parts of the lab, we work on advanced commercial technologies, but what we're also doing here is looking at technologies that are 5 to 10 years out. So how can we take physics and make it work for us in order to improve the performance of them?
And so I noticed you have this really...
Yes, our MBE.
Yeah, this is like out of Star Trek here.
It is, yes. So this is a molecular beam epitaxy. And so we use this to very precisely deposit materials and make a solar cell out of those new materials. So this is actually pretty cool. So this is the main chamber over there. It's got incredibly good vacuum. In fact, the vacuum in there is better than the vacuum in outer space.
Wow.
And in the back, we have all those sort of little spiky things sticking out. And those are what we call sources. And they deposit material atom by atom onto a wafer.
So you're creating I guess a wafer is a solar cell?
Yeah, we'll turn into one once we put metal and stuff on it. So,
and atom by atom, this machine
places down layer by layer. So we use it to look at new materials. So in solar, the performance we get out is very dependent on the materials we use in the solar cell. So present solar cells are often made up of silicon, which is the same material that's in your computer chips and things like that. Mm-hmm. In order to get higher performance, what we can do is put other materials on top of the silicon. So they're often gallium arsenide based. Now gallium arsenide is what lights up. If you see a red LED or in your phone, you've got a couple of specialized pieces that are gallium arsenide. So we're trying to take that technology and apply it to solar cells.
Wow, that's really interesting. Fantastic. Thank you for taking the time to talk to us about this.
My pleasure.
What's happening here at the Arizona State Solar Power Lab.
Thank you very much.